I'm going to go over the problem stock buy and sell. Maximum one transaction allowed. First, I'll go through the problem statement. Given an array prices of length n representing the prices of the stocks on different days, the task is to find the maximum profit possible by buying and selling the stocks on different days when at most one transaction is allowed. Here, one transaction means one buy plus one sell. Note the stock must be bought before being sold. So, for example, we have this prices array is given to us 7, 10, 1, 3, 6, 9, 2. Output is 8. Buy for price 1 and then sell for price 9. Buy for price 1, sell for price 9. Basically, we need to get the maximum profit possible by buying and selling stocks on different days when at most one transaction is allowed, right? So, for example, another example is 76431, 0 is the output. Since the array is sorted in descending order, zero profit can be made without making any transaction. Because if we buy an earlier day's price, right, a stock of a price, sorry, stock, if we buy a stock at an earlier day and then we are aiming to sell it at a later day, then we realize that since this array is sorted in descending order, every time we buy, we will have higher amount earlier and a lower amount later. So if we are buying let's say a profit stock of price 7, then we'll have to sell it at a lower cost. There is no other case where we can find a higher cost than 7, because this array is sorted in descending order. So that is why zero profit can be made in this array. Next, moving on, we have 1, 3, 6, 9, 11. So this is sorted in ascending order. So we can make maximum profit by buying buying the lowest price, that is 1, at price 0, and selling at price of n minus 1, that is 11. So 11 minus 1 is 10. That is the profit. Right now, first we'll discuss the naive approach by exploring all the possible pairs, which takes O of n square time and O of 1 space. So the idea is to use two nested loops to explore all the possible ways we can use to buy and sell stock. The outer loop decides the day to buy the stock, and the inner loop would decide obviously the day to sell the stock. And the maximum difference between the selling price and the buying price between every pair of days will be our answer. So let me show you the code as well. Yeah, you can see n is prices.size, result is 0. So explore all possible ways to buy and sell stock. This is for buying, I is for buying, and j is for selling. So result is maximum of result and prices of j minus prices of I, and return result. Now the expected approach is the one traversal solution that takes O of n time and O of 1 space. So in order to maximize the profit, we need to minimize the cost price and maximize the selling cost. So selling price. So at every step we keep track of the minimum buy price of stock encountered so far, and for every price we subtract with the minimum so far, and if we get more profit than the current result, we update the result. So how it goes is, minimum so far is, let us say we are setting it to prices of 0. Then for I is equal to 1, I less than prices or size, I plus plus, we update the minimum value seen so far if we see smaller. Right? If we see a smaller value, we update the minimum value and update the result if we get more profit. So get the maximum of the difference between prices of I and minimum so far. So this takes O of n time complexity, as we are traversing the prices array only once, and auxiliary space over 1. Now moving on to another question which is similar, that is stock buy and sell where multiple transactions are allowed. Right, so this is a similar question, but here instead of one transaction we have multiple transactions allowed. So basically, given an array prices representing stock prices, find the maximum total profit that can be earned by buying and selling stocks any number of times. Right, so the condition is now any number of times we can have, so multiple transactions we are having. So we can only sell a stock which we have bought earlier, and we cannot hold multiple stocks on any day. So let us say this is the prices array: 100, 180, 260, 310, 410. Now I buy the stock on day 0, that is 100, and sell it on day 3, that is this point, 310. So we get 310 minus 100, profit as 210. And then buy the stock on day 4, that is 40, using the cost 40, and sell it on day 6, that is 695. So profit is 695 minus 40, 655. So the maximum profit is, we add these and get an answer 865. And this is the graphical representation of this. So you can see we buy at this point at day 0 at cost 100, and sell it at a price of 310 on day 3. Then buy again at 40 on day 4, and then sell it at an amount of 695 on day 6. So the total profit we acquired is 210. That is the difference between 310 and 100, and 695 and 40. We add these two and we get an answer. The explanation is stock prices keep decreasing. There is no chance to sell at a higher price after buying, so no profit can be made. Now naive approach is by trying all the possibilities. That takes O of 2 to the power n time, so that is exponential time, and O of n space. Idea is to use recursion to simulate all choices of buying and selling. For each day, you can either skip it or buy on that day. If you buy at day I, then you try all possible selling days, j greater than I, where price of j is greater than price of I. So recursive function to find maximum profit. So this takes we take the price vector, the start and the end vector. Sorry, start and end integers. That is the day, and result is 0. So try every possible pair of buy I, that is denoted by I, and sell, that is denoted by pointer j. So for int I is equal to start, I less than n, I plus plus. For int j is equal to I plus 1, j less than equal to n, j plus plus. Valid transaction if the selling price is greater than the buying price. So if the price of j is greater than price of I, that is if the selling price greater than the buying price, that would be a valid transaction because we are making profit. Then we add the current profit plus the profit from left and right parts. So current is price of j minus I, price of j minus price of I, that is the current profit, plus the profit from the left using recursion, max profit recursion, price start to I minus 1 and then j plus 1 to end. So we add these two and we store the maximum result and just call the maximum profit recursion function in the main function starting from the 0th index and going up to the n minus 1th index, right? So we get the output. Now a better approach using local minima and maxima that takes O of n time and O of 1 space. So the idea here is to traverse the array from left to right and find the local minima. That is where the price starts rising. Local minima is the lowest most point from where the price would start rising, and then find the local maxima. That is where the price stops rising. Compute the difference between the two and add to the result. Right. So here let us see how it goes. The whole run through of this algorithm. So first what we do is initialize the local maxima and local minima with the first element of the array. So we have set the local maxima and minima as the first element, and then we will be traversing and updating. So we need to maximize the profit using local minima and maxima. Total profit initially is 0. Now what we do is the stock price on the current day, that is at I, is 100, and on the next day is 180. As the price is increasing, 100 will be the local minima, so we set the local minima, which is already set to 100. Now we buy the stock at 100, right? The I pointer is here. Next we move on. We update the I pointer to the next index. Now stock price on current day is 180, and on next day is 260. As the price is still increasing, that is 180 is going to 260, it is still increasing, and we have already bought the stock at 100. We hold the stock, right? We hold that stock because this is the local minimum. Going over to the next day, now you see stock price would be 260, and the next day stock price is 310. As the price is still increasing, we have already bought the stock that at our price 100. We hold the stock, right? We do not update the local maxima, right, yet. Now what we do, now the stock price on the current day is 310 when we have updated the I pointer, that is went to the next index, and on the next day is 40. Now as the price is decreasing, 310 would be declared the local maximum because it first went from 100 to 180 to 260 and to 300, right? It reached a local maxima and then it dropped to 40, right? So this is the local maxima and this is the local minima here. Now the price increases to 535 and then 695. So you see this also would be a local minima for 40, right? And that was the graph that I showed you in the beginning. So we set the local maxima here, and total profit would be local maxima minus local minima, that is 210. Here it has been updated. Next, stock price on current day is 40, and on the next day is 535. As the price is increasing, 40 will be the local minima. Then we buy the stock at 40, buy the next stock at 40. Now the local minima is 40, and we check for the next day, that is 530. Sorry, we check for the next day, it is 535, and the next to that is we have the local maxima. So we sell the stock at 695, and therefore our profit would be 695 minus 40 for this stock. So that would be 655, and then we add it to 210, so we get the total profit 865. That is the whole run through of the algorithm. Now let us see the implementation. So n is the size of the prices vector, L min is local minima, and L max is local maxima. We are setting it to the first element, price of prices vector. Result is 0. Then we start at index I is equal to 0. So while I is less than I is less than n minus 1, that is the last index, we find the local minima. So while I less than n minus 1 and prices of I is greater than equal to prices of I plus 1, while I less than n minus 1 and prices of I greater than equal to prices of I plus 1. What does this mean? That if the next one, let us draw this first, right? Let us say we have 100, and then we have 200, and then we have 300, and then we have 40. Let us say this is the array given to us. So we have to find the local minima. While I less than n minus 1 and prices of I is greater than equal to prices of I plus 1. So we check, is prices of the current index greater than equal to prices of I plus 1? No. So therefore we go on to the next index, we update I. L min is actually prices of I. So L min we set to this, that is this, local minimum. And the local maxima is updated when prices of I less than equal to prices of I plus 1. That is the next index, index or next element's value is greater than the previous one. So then we get the local maxima and we update it and add the current profit res plus L max minus L min. That is our second approach, and we get our output. Now by accumulating profit, this is another expected approach. It also takes time O of n and space O of 1. So the idea is that profit only comes when prices are rising, right? So if the price goes up from one day to the next, we can think of it as buying yesterday and selling today. Instead of waiting for the exact bottom and top, we simply grab every small upward move. Adding these small gains together is the same as if we had bought each valley and sold at each peak, because every rise between them gets counted, right? So let us see this approach. We have initializing the total profit with 0 initially. Then the price of the current day is greater than the price of the previous day. So buy at 100 and sell at 180. So we get 80 as a profit. Then moving on, 260 minus 180 is 80. We add another 80, right? Then moving on, 300 minus 260 is 50. So we add 50 to the profit that we had. So total profit becomes 210. Now we see the price of the current day, that is now we are at 40 index with element 40. The price of current day is smaller than the price of the previous day, so we skip the current day since this is larger. 310 is larger than 40, so we skip the current day. Moving on, the price of the current day is greater than the price of the previous day, so we buy at 40 and sell at 535. You see, the price of current day is greater than the price of previous day. So 535 minus 40 is plus 495 profit. So we add it and we get our total profit right now 705. Now we see the price of current day is greater than the price of the previous day. So we buy at 535 and sell at 695. So total profit becomes 865. Right, and the implementation you can see max profit is, we set the result as 0. Keep on adding the difference between adjacent when the prices are greater than the previous element. So for I is equal to 1, I less than prices or size, if the prices of I greater than prices of I minus 1, that is if the current element is greater than the previous element, then we add it to the result and we return it. That's the simple answer we received. We get 865. Now these are the related problems, so we can I'll cover all these remaining problems in the next video.